Good morning. My name is Dr. Steve Livingston, and we're standing here on the Texas A&M Mini Farm Annex, which is the site of much of the profit work that we conduct with the Sorghum Profit Initiative here in South Texas. Before us is several of the sorghum tests that we are conducting here in 2002. The work primarily is with iron chlorosis and trying to find new and alternative ways to subdue chlorosis in sorghum fields. As you know, sorghum is sensitive to high pH calcareous soils, and a lot of times the plant will develop chlorotic symptoms when it's very juvenile. Sorghum iron chlorosis is one of those problems that affects at least a third of the soils in South Texas, and hybrid selection is very important to minimizing the effects of sorghum iron chlorosis on yield. We have observed that there are several hybrids that have more tolerance or more resistance to the chlorosis problem, probably because of the root system they have and the exudates that interface with the soil particles. But these sorghum hybrids maybe only have to be sprayed once with iron sulfate, and then the producer is free to do some other things that he needs to do, and he doesn't have to come out and spray 2 or 3 times. So these hybrids have given us anything from 50 pounds to 1,300 pounds of additional yield. So we're still identifying those, still looking at the ones that perform the best. And as hybrids change, it's necessary to stay abreast of these things. So it's something that probably will not be fixed until we have some kind of genetic engineering initiative that takes one of the genes that really makes, like corn, it is more efficient in utilizing iron. The sorghum plant will be then altered in such a way that it is not affected by iron chlorosis. Iron chlorosis is very visible in the field because it shows up as yellow or off-color plants that are usually stunted, and if the iron chlorosis is very severe, they may even turn white or be a very bright yellow. The plant that is we're looking at here on your left is expression of iron chlorosis, and you'll see some striping, and you'll have also some scorching that happens from the sunlight as the tissue is exposed to hot temperatures and dry weather. That tissue will tend to die. The idea is to get some iron sulfate applied to these plants while they are much smaller than the one I have in my hand. As soon as there's enough leaf tissue, like 3 or 5 leaves, an application of iron sulfate should be made, and with that, it is absorbed by the sorghum plant, and the recovery process is on the way. Usually takes 2 to 3 applications, though, of foliar iron, and if that is done and done well, then usually the plant can go ahead and produce a head or a panicle. The plant on your right here is the more mature sorghum plant that has the characteristic striping that occurs in late season expression of iron chlorosis. Now, where you have chlorosis, you're going to usually have somewhere between 3 to 5 days later heading and maturity in light case of chlorosis, but it could be as much as weeks. And this sets off a tremendous problem in controlling sorghum midge, because you'll have all ages and types of plant out there, and it's almost impossible to scout and to do a good job spraying for the chlorosis. Chlorosis occurs when we have a high pH soil, usually one that's above about a pH of 7.8. It begins to show up, and highly calcareous soils. The salt also has some tendency to make the iron less available, but sorghum is one of those plants that is not as efficient as corn and some of the other grains in extracting iron from the soil. So it is necessary to have these foliar amendments to correct chlorosis where you do not have a hybrid that has a tolerance to the chlorosis.